Hello everybody, welcome to, we're doing enemy behavior today. So first of all, first thing you can do is if you go to our student organization site, I hear one person already got it. If you go to our student organization site, this link up here, or if you just go to stu.org and then search GDC, you'll find the club. And then you go to the downloads tab here. We've done this for like all of our workshops. You should see enemy behavior. I'm assuming it works then if you can download it over there. So go ahead and download that. That's a Unity package. That'll have some of the assets that'll speed things along and make things a little bit quicker working. So after you get that downloaded, set up, you want to make a new project in Unity. So this is mine. Peace. And then import it. We've done importing packages before. And you want the enemy behavior workshop. There's some really simple stuff in here. Some materials, a sound, a couple scripts, a couple scenes. Just import all of it. Hopefully yours will be faster than mine. So under scenes, we have two scenes. We have empty and we have, this is called sample scene? Is that what it's called? I thought it was called walls. Anyways, the important thing is you can see that this is the, oh god, what did I do? Oh no. How do I get that back? My Windows got all messed up. Yeah, I guess. Where's that? Window and layout. Revert back or default.
Yeah.
All right, I'll use poop layout for a bit.
Yeah.
This is fine. So game view. So all our game has right now is it's pretty simple and it is definitely playable right now. Where when you press play and it starts eventually, you got a character. You can move, and when you touch the enemy's line of sight, which is the red, supposed to be like the red light emanating from them, they spot you, and then it resets the. So your goal is just to avoid being close to them and in front of them. You can pretty simple layout. I won't bother going through the code. It's mostly stuff we've seen before. So let's see. So first things first. For the people that just came, we downloaded the package from this site. So the student organization site, our club, and then downloads. And it's the top one, enemy behavior. And then you can create a new Unity project and import it into there. So if we want to make this better, if we're trying to set up an enemy, what is one thing a lot of enemies do? The most basic thing enemies do. If they know where the player is, they go to the player. It's pretty simple. It's if an enemy is if the enemy defeats you by getting close to you and facing you, they want to travel towards you. So we can set that up. That's really easy to do. So let's start with a simple navigating code, I guess. So go ahead and open up the enemy script. We'll just edit that. That's easier than making a whole new thing. I swear it's opening. My computer just takes a while. So, first of all, you'll notice that this script has plenty of stuff in it already. Some pretty simple stuff. Basically setting all of this is for making it so that when it spots the player, when the player's near it and it's facing the player, it makes the noise and then reloads the scene. So pretty simple.
Is this 3D or 2D?
3D. 3D. 3D will be easier than. Yeah. I mean, it is kind of 2D because it's top down, but 3D perspective, and it's easier to work in 3D space with this. So with this code, the only thing we care about right now is the fact that we know where the player is. So a lot of games, the challenge of a lot of games is trying to make your enemy seem like a player or seem like something that has some form of intelligence. So we're going to design an enemy that doesn't have that just to start. We're going to design an enemy that always knows where the player is at all times. So we have our player already set here. And we find them just by finding an object with the tag player, which is the player. So that's easy. So this part here is where we're going to be actually putting stuff. You can ignore all of this stuff down here. It's just boring light thing. So first things first is we can move towards the player. So this is a very simple thing to do. So if you have 2 points, I feel like I need to work in like paint for this. Because I would draw it on the whiteboard, but we don't have a working marker. And also that won't show up in the recording. So, okay, a little bit bigger than 8 pixels by 1 pixel, please. All right, so if you have an object here labeled P, and we have our enemy here, that's E for enemy. And you heading out, Jamil? Yeah, peace.
Thanks for going.
So if we have a position system, if we're using coordinates or whatever we want to call it, how would you get this vector? It's not a trick question. It's pretty simple.
Subtract the position.
Exactly. All you do is you just subtract the position. You take the player position and you subtract the enemy position, and that gives you the difference. That gives you that vector pointing towards the player. So all we need to do for movement is, if we're just changing position, which is what we're going to start with, we're just going to alter position. We can do transform.position plus equals, or I guess if we want to be better, we can probably do transform.translate. That's sort of the same idea. So this is just taking our current position and it's just adding something that we're giving it. So we can give it the player.transform.position minus the transform.position. So this is the position of this whatever this is attached to. So it would be the enemy. So translate that. Great. Okay. What are some problems with just writing it like this? There's like 4. So
Well, it'll go to the player even like.
Yes, that's true. But if for this situation here, we don't care about that. It just knows where the player is. It's the all-seeing, whatever you want to call it. It knows.
God.
It knows exactly where the player is at all times, because why not? So there's one obvious small problem with this, and this is just basic Unity stuff, and that is we're not multiplying this by time.delta time. So that should be top of the list of oops, that's not what we want to do. So the reason we multiply by time.delta time, for those that don't know, multiplying by time.delta time gives us that's the time since the last frame, so that normalizes the movement. So if we have frame skip, if our game is lagging, it'll still move the same distance in the same amount of time. So that's just standard. Another thing is we don't really have a speed for this right now. It's kind of just moving at whatever speed. So that should be, so if you go to the top and add, I'll put this at the bottom so it's more clear what we're adding. Public float, I'm just going to call it speed. Just the movement. It's just the speed at which the enemy moves. Should be pretty simple. And we can just multiply this by speed. So right now we're moving. We're doing time.delta time. We're getting some speed that we're setting. There is one other problem that is very significant. I'm curious if anybody can spot it. We can run it. You know what? Let's run it. Let's see what it does, because it's interesting. That's for sure. So our enemy, once this updates.
Did you add in rotation?
No, I didn't do rotation. That is a problem, but that's not what I want to. That's not quite what I want to highlight. So let's do 10 for now. And let's see what it does. Oh my god.
You reversed the transfer from the top position to the position.
Also, it looks like it went up there.
No, that's the player position minus this position.
It looked
What's
like it was early.
what did I mess up?
I switched this to a different.
Wait, what? This is moving the enemy.
So we're subtracting the starting, or the ending point from the starting point.
Yeah, wouldn't the ending point be the player?
Yeah.
So you subtract that from the yourself, or from the enemy.
Let me just try something real quick, because I think from the position was giving me something weird. Let me see if it was Okay.
They don't have that area.
Where are you, enemy? Where did you go?
Slow down speed.
He's somewhere. He's somewhere here.
Oh, he's on top of the player. He's inside the player.
No, because the light wouldn't the light be? I can't even move. Okay. Okay. I do know a problem with this. The problem that I was trying to highlight, that apparently I don't know what the is going on. So one of the problems is we're not normalizing this vector. So if this vector has a magnitude of 10, we're moving at 10 times the speed. And when we get close to the player, it slows down because the distance gets shorter. So if what you want to do is you want to normalize the vector first before you start multiplying things like speed. Normalizing a vector just makes it length 1 all the time. So what we can do is we can just add dot normalized. So whenever you have a vector 3, you can just add a dot normalized at the end of it, and that will give you the length 1 of it. So now we have, this is the important bit, that we have the positions, and we're normalizing it. And I might have to switch it. I don't know. The reason I wasn't switching it when you said it needs to be switched, but it's because before normalizing it, I didn't know which was doing what. So. Yep. Okay. He was going in the wrong direction. How did mine work at home then? I don't know. Anyways. So switch the so it should be transform.position minus player.transform.position. And that should get it to move correctly. So we've now got the enemy following our player. I think it's moving a bit faster than our player. It fell through the floor. How?
Just watching the Y position.
Didn't I freeze the Y position? How did that happen?
Because you're freezing it in the ridge body and you're doing it with translate.
It might be, but it is clearly falling afterwards. Whatever. Anyways, so now we can get it to face. Getting it to face the right direction is ridiculously easy. A lot of people have trouble with this because they try to use transform.rotations and trying to do .lookat. Turns out there's something really, really easy to do, and that is you can just directly edit what the forward vector is. So all we need to do is just say transform.forward is equal to transform.position minus player.transform.position. That's it. So we're just setting it to the same thing as the direction we want to go when we're moving. So all it's doing is saying the direction we're moving is the direction we're facing. Pretty self-explanatory. What's that? So I'm also going to slow down the enemy a little bit because I think he was going much faster than I was. Let's see if it worked, or if he's going to face directly away. I hope. Now he's moving directly away. Why did that change?
Maybe you did have it the right way, and then it was. Wait, never mind. That wouldn't make sense.
You know what? Let's do this, okay? I actually think I might know the problem with it. It might be that transform.translate does it locally, based on local space instead of world space, which would be a problem.
Well, then you would just go forward after doing the forward, right?
Yes. But I also want to see if this will... We're going to kind of improvise a little bit here. Because apparently this doesn't want to work with me. The second way we're going to do it is going to be a lot easier. But it should be a lot easier. Yep, still going the opposite direction. Okay, so then... So if I reverse these again... I think it did have something to do with local something or another, or it just decided to flip things for literally no reason. Either way, your code should look like this. I believe should be correct. Should. So I'm just gonna start doing that. Jamil, cut out the part where I looked incompetent. Thanks. All right.
You think he watches all 2 hours of it every time?
Of course. No.
Where is speed modified?
So if speed is a public variable, then under the enemy script, when it's attached to the enemy here on the right, we'll be able to set the speed. So I have it at 5, and the enemy follows fairly closely, I guess. So we're also getting lighting issues, but I don't care about that. So our player has a current speed of 10. If we set our enemy speed to, well, let's set it to 10. There is a problem with this, and that is, how do you escape? If you're moving in a straight line, you're fine, but if you don't move in a straight line at all, he does get closer and closer, bit by bit, to the point where you eventually get caught, regardless of what you do. So this is an example of a really simple and kind of naive approach to making an enemy path towards you. There's benefits and there's problems. The benefit is it's super simple and the player knows exactly how it's going to work. Problem is it doesn't look like a person controlling it. No person perfectly follows you and knows exactly where to face. So one of the ways we can fix it is by changing something else. So here we are basically setting the velocity. We're setting, I want this thing to move in this direction. What we can do instead is we can change the acceleration. So if we have the rigid body, we can tell it accelerate in the direction of the player. So if it's moving towards the player and the player goes around them, they'll actually take a wide turn and try and follow. Like they won't be able to follow quite as easily. So really, there's a really easy way to do that. So I'm going to comment out the lines we put here as we're going to be doing something else. So just under public float speed, I'm going to put a rigid body RB. And under start, I'm going to be putting this command. So this is something we've used before. This just gets us a reference to the rigid body attached to this object. So now we can modify parts of it. Pretty self-explanatory. So as new code down here, I just remembered I can zoom in and help people. Sorry about that. As new code, let's do RB dot add force. So adding a force it basically just gives acceleration in that direction, and you can use different force values. And so then all we need to do is delete this because I'm being an idiot. I forgot about this. Sorry, we want to work in fixed update. I forgot that fixed update is basically if you're doing anything with physics like rigid bodies, you want to put it into fixed update, not update. Because fixed update runs at the frame rate. So every frame update runs once. Fixed update runs with the physics. So it's better in terms of physics stuff. So we can do rb.addForce, and we can put in the exact same stuff we had up here. This.normalize times all of that. We can just copy it directly and slap it in. Although we can get rid of time.deltaTime. Fixed update automatically does things at a set rate because the physics runs at a set interval, so you don't have to deal with time.deltaTime for that. So
I've seen time.fixed.deltaTime used to create like a 2-scale representation of the 1 meter in editor to meters per second.
Yeah, you can use that for per second, but you know, for the sake of this, it might be easier just so we can use the speed interchangeably and not have to modify it. So sure, we can put that in. That is time.fixed.deltaTime. You could put that in or you cannot. It's either way. This just makes it per second, and that is useful. So yeah, so this is just adding the force, same direction vector we had before. We're normalizing it, multiplying it by the speed. Pretty simple. Last thing we can do is we can set the transform.forward to make sure it's also facing the right direction. So this is very similar to the one above it, except way simpler. We do transform.forward is equal to rb.velocity. And would you believe it, it's just that easy. All we're saying is the speed that we're moving is the direction that we're facing. So Let's give it a shot. I'll keep the code up for a bit. Oh god. Okay, so how does it run? To someone who's done it, does it not?
I'm getting a bunch of errors.
Oh god, what did I do? What have I done?
I'm not sure.
You didn't get any errors.
Look rotation.
Oh, okay.
What's that doing?
Getting the type or namespace, rigid body.
Rigid body cannot be fed. That's something different. Did you spell rigid body correctly? That might be an issue. What did I do, Sam?
I'm paying very much attention. Scroll down.
I swear this should make sense. This is all I'm doing is I'm just adding
Where is it?
add a force. Well, we can also add a force mode, I guess. So you can do force mode dot, and then there's 4 different options. So if we want to do something continuous, we can just select acceleration, which is basically what we're trying to do anyways, so that works. I think it's a problem with this transform.forward and getting this.
Well, you can just comment that out because it doesn't really matter.
Yeah, we'll see if it works. I think the problem is it's starting with a velocity of 0, 0, 0, and it's trying to set the forward vector to 0, 0, 0, which isn't a thing.
Yeah.
So maybe that's the... Because it's saying that the forward thing is 0. So.
Error, though. That's just a console log.
Let's see. All I care about is it moving towards me?
It's not.
It's not. Great.
Kind of weird.
Let me try bumping up the speed. No? It's not speed? What do you mean yours kind of... Okay, yes, it is speed. It looks like it's depending on the speed. So try bumping up the speed to like... What does 1,000 look like? Let's see. Depends on if it ends instantly. Hey. So as you can see now, it actually overshoots and tries to follow.
That rotation back.
Come on, try it. You won't. And of course it can lead to some silly stuff like this where you can sort of lead it around. But the idea is this looks at least a little bit more realistic a lot of the time when it comes to following the player, that it's not perfect. So I guess if we want to set this, we could just do a simple if. Just say if. So I'm curious, this probably will fix it then. If we just say, if the velocity is not 0, then set it. Because I'm sure that that's the problem. Of when it has a velocity of 0, it doesn't want to work correctly. Yeah, there we go. So now our enemy is trying to follow us. And it's at least a little bit easier to avoid them. Oh, just kidding. Not if you suck. Then it's probably just as easy. So even though our player is moving much faster than us, we can avoid them. So there's a few ways to approach this of making it better. So one of the ways is we can get the player's, so if we know the player's speed, we can predict where they'll be. That's one of the things you can do. Where you can keep, as the player, you can say, okay, if in 1 second the player will be in this position, if they're going to keep the same speed, I'm going to aim there. And then the closer you get, the less time you predict ahead of it. You could set up something like that to follow them, and it would work great. I'm not going to go into that because we've got other stuff to do, but that is a way that you could easily do it. So this is great. Setting it up so that it simply follows is fine. The problem is it doesn't really work for quite a few situations. So the other scene, not the empty one, has some walls that really mess up our code. They really make it so that it doesn't want to work quite as easily. So when we try running it here, you'll notice the immediate problem of our enemy kind of just gets stuck on things. Because our enemy's stupid. He's just trying to walk towards us, and that's it. So nice job. That was an easy game to beat. I stand in the corner, and the enemy also stands in the corner and has no idea what to do. And I can go and wander the world in the bottom right for, as much as I want. Obviously, this isn't good game design. So we can design an AI, or design an enemy that can. First, we'll design an enemy that has a set path. We can just do very simple state machine. And then, assuming I have time, I'd like to get into pathfinding, because Unity has some really convenient, really fast ways to do pathfinding. So, first things first, we can do a few different things. So, number one, we know where the player is, but we don't want the enemy to know where the player is. What you can do is you can program in stupidity in your enemies. So even though the enemy script knows where the player is, you can check if they can actually see the player. So just because we don't want the enemy to know where the player is doesn't mean we get rid of our reference to the player. So one way to do that is to raycast. So what you can do is you can raycast at the player, basically shoot a line at them and say, can we see does this line connect to the player without hitting any walls? If so, follow the player. Otherwise, don't. Pretty simple, pretty basic. So what we can do is we can add a boolean. So bool can see. Can this enemy see the player, basically? And we'll set this to false initially. So I'm going to put this above the other code we've done. We can set up our ray. So have we done raycasting in here, actually? Do you guys remember raycasting? I guess we haven't, yeah. Well, introduction to raycasting. So rays are basically, it's basically just a single line that contains information. Usually information's on the colliders it is hit. You can set a ray to just pass through everything and give you all colliders, or you can set it to only give you the first one with like which one it hits. There's all sorts of things you can do. So I'm going to say ray, lowercase ray, we'll just call it that, equal to new ray. We can put a few things into it. So we can put in the origin, which is pretty simple. This is just our current position, transform.position. The direction, so this is where we can use that vector we were using before. So player.transform.position minus transform.position And bada bing, bada boom, we're done. That creates array. So we haven't actually done anything with it. This is just saying we now have this thing to reference. So now we can do Raycast Hit we'll call it Ray Hit, sure. It's equal to new Raycast Hit. Or is it Ray.cast? I'm trying to remember the exact.
It's been a while since I've used Raycast.
Yeah, I know, right? I'm pretty sure you do. No. Yes? Oh my god. All right. No shame, we're looking at the documentation. I think literally every single time I use a Raycast, I end up looking at the documentation. The functions are kind of set up in a weird way, so physics.raycast. God damn it. Okay. So yeah, okay. So that's right. So we do want a Raycast hit. So we can do a Raycast hit, and I'm just going to call this hit. So this is what's going to store our information. So we've got our ray, which is going to shoot in a direction, and we've got the hit, and this is going to store what it has hit. Then we can do physics.raycast. So Raycast has a few options. Raycast sends a ray and gives you the first thing it hits. Raycast all will give you everything that it hits. And we don't care about that. Raycast or Raycast all are basically the two that you want to look at. So we're going to do Raycast because we don't want anything past the first thing we hit. So physics.raycast. Now we can give it a ray. So we've got our ray, lowercase ray. What? Yeah, I know. There's a way to get the hit to actually store the hit somewhere. One of the parameters has this Raycast hit. This one has a really confusing parameters that makes it really obnoxious. I think it's this one. That if we do the ray and then the hit, and then we can do some of that stuff. So ray, and this is kind of confusing. I run into this error literally every time I try to use Raycast. When you want to use the hit, you need to do out and then the Raycast hit. You can't just type the hit, otherwise it literally explodes. So it's got a range of infinity. We don't really care about that right now. We can give it a set range. It's not that big. When I was doing the enemy challenge workshop, I gave it a set distance, and that was the range of which you could approach it. We're just going to give it infinity here.
Can see forever.
Yes, it can see into the void and beyond. So max distance, layer mask is one of the most obnoxious things to deal with. I'll say that much. But they've luckily got an easy way to deal with it. So sometimes it does not like it when you just give certain things because it's only got so many. We'll see. Maybe this will like it and not immediately explode. It also might just immediately explode. Okay, it didn't explode. Great. We'll stop there then. So this now gives us our information. So this is letting us know, have we hit anything? So before we go any further, The issue we can run into is what happens when the object casting the ray hits itself, which is a problem way too much. So an easy way to deal with this is you can set a layer for objects, most are default, and one of them is ignore raycast. Already set up to just make it so rays pass right through it and don't bother it whatsoever. So we can set our enemy to ignore raycast. So now our ray will never hit our enemy because it just goes straight through and never bothers with it. The reason layer masks are awful is because if you wanted to ignore other layers, you can't just say ignore a layer. You have to give it a number of it's like a binary thing, that each layer is a digit in binary of whether it's 0 or 1, and you have to actually get the integer number of that binary based on the layer. It's a nightmare, and it's just not a good way of doing it, but that's the way they do it, so I'd suggest not trying to deal with that if you can help it. So here we can do. We should also do an if for this. This is a good point. An if for the raycast, because we don't need to be dealing with the raycast if it doesn't hit anything. For our game, it should always be hitting something. It should always be hitting the player or a wall. There's no situation it wouldn't, but it's always safe to do this anyways. So if we're hitting something, which we should be, now we need to use our hit. So our hit has been modified. So we can give an if hit dot collider. So this gives us a reference to the collider that got hit. Compare tag. This compares the tag of the game object it's attached to. And then we can just give it player. So if the object we hit, if the first object we hit is tagged as player, do the thing, basically. All we need to do is set our can seeds to true, so that we can now see the player. And then we can give it an else of if we can't see the player, then we can't see the player. This is also where you could put, I'll put this in. It's, again, unnecessary for this game, but we can also put that if the ray never hits anything, then obviously we can't see the player. This would be useful for if we had a certain range. So, this shoots our ray. This will get first object it touches, and we are looking for the player. Pretty self-explanatory. Any questions about this so far? Other than, Jake, why are you so ill-prepared? Which is totally a fair question, to be honest.
Why are you so ill-prepared?
I was up till 1 in the morning working on a 419 lab, so...
Why are you so ill-prepared?
It's not an excuse, Jake.
I wasn't doing so great in a lot of this prep, so sorry about that. I swear usually we're better at this. So, now that we've got our can C, all we need to do is, in here, when we're actually adding the force, we can just put if you can see the player, move to the player. Wow, revolutionary, crazy. So, now at the bottom, this is what I added. If we can see, go there. And this is setting if we can see using raycasts. Raycasts are a nightmare to program because I think the way they're set up is just obnoxious, and I have to look at the documentation every time. But they do a lot of useful things, like a lot of useful things. When we talk about being able to jump, detecting when you're on the ground, one of the ways you can do it is to cast a ray downwards with a very low distance and see if I'm intersecting the ground. Pretty simple way of doing that. So, let's bring it in. Hope it doesn't die. I'm sure it will. Nice, no errors. So let's see, if our player doesn't move, that means we did it right. Okay. So player doesn't move, they're chilling, they're just sort of hanging out. But when I look around here, oh, he gets angry. And he starts chasing me. But once I'm around the corner, he doesn't see me anymore. But if I come back out, he sees me. So it's simply drawing a line. So right here, it would be drawing a line. Yes. I think so. I think I do have friction. He's got his Y position locked. So it might be something with he's not actually touching the ground properly. I don't know. Yeah, I'm not really concerned about it right now. So, but yes, there's a few ways. There's a few ways we could make that better. So, useful way to. I'm gonna have to look this up too. Useful way to see rays is there's a debug command that draws the ray in the editor window, which is super useful. I believe it works fairly similarly to drawing arrays. I'm just going to copy this directly in. We can work with it. So here I'm drawing the array. Great. I'm also going to call debug.drawArray, and we can give it our starting position and our direction, which is the exact same two things we put into the array originally. And we can give it a color, so I'll just make this white. Duration 0, really? Oh, we don't have to give it the rest of those. Cool. Those are optional. So this is what our debug command looks like. Pretty simple. We're giving it origin, direction, color. And this can be super useful when trying to deal with rays, especially if you don't know why your ray isn't working. It can be useful to make sure that you've actually got the right position and direction, because that's an easy thing to mess up and not realize that you've messed it up. So if we run our game alongside our view so that it's clear of what's going on, we should be able to see, yes we do, that we now have in the editor we have a line being drawn where the ray is actually being drawn. So you can see the second that ray is outside of the wall, it starts following. Very useful for debugging rays. Oh, that was unfair. Got me through the wall. What? Okay, I clearly didn't think about that. But that could be something that would be useful for instance, seeing if you know where the player is. That you could draw a ray. So I didn't do that. I just did it based on distance, and he can see through walls. So doing rays would fix something like that. So, does anybody have any questions about line of sight, basic line of sight stuff? Anything? Okay. Now, I'd like to do some really basic state machine stuff. So, does anybody not know what a state machine is? Okay, so a state machine is just cycling through different states of the object, so we can set so for instance, if we want our enemy to patrol, so we want them to walk around, let's say, the 4 outer walls, a state machine would say, there'd be 4 states: walking right, walking down, walking left, walking up. And it would just cycle through them. So based on some criteria, it would move from one state to the other. That criteria probably being it hits the certain waypoint that we want it to hit and go to the next one. So we can set up a really basic state machine to actually have our enemy patrol around the outside and, you know, see what's going on. So I'm not going to get rid of this draw. I'm not going to get rid of this whether they can see the player. I'm going to try and implement that into here. So let's see. We can set up our states. So easy way to do states, great way to do states, is to use enums. So an enumeration, is that the full name? Enumerator? I feel like it's an enumeration. I don't know. Enums. Nobody knows what the full name is. Nobody cares what the full name is. Enums are basically just like static identifiers for something. It's basically just an integer, and then you can compare them, but it's a nice way of naming the integer to use. So we can use enum state, and then I think it's just open these. I don't think we have to do any equal stuff. So we can set our states. So we can set state I'm going to do walking, stopping, chasing. Or I guess, well, yeah, that's fine. Yeah, that's good. So the idea behind this is we can have it walk from waypoint to waypoint. When it gets there, I'm going to have it pause for a little bit, seconds, and then it's going to continue walking. But if at any point it sees the player, it's going to start chasing them. And then when it can't see the player, it's going to go back to whatever its previous state was. So let's try and set this up. So easy way to do this in an update is a switch statement. So if you haven't used switch statements before, these let you it's basically like an if statement with a bunch of conditionals that you can say if it's equal to this, 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 or this. Way easier to use a switch. So I am getting a little bit ahead of myself. We do need to actually create a state. So we can use it as a type. So we have a state. I'm just going to call it current state. So this is the current state that I'm in. Let's set current state to walking. State.walking. So it's just going to default at the very beginning to walking. We're going to be walking from one waypoint to another waypoint. Pretty simple. And so we can set up our switch statement. So we can switch our current state just like this, and then you use the word case. Case keyword for this. And so I can say if it is state.walking, do something. And then you need to use a break statement for switch statements. So a break just says exit out of the switch, so it doesn't run through all of these. Then case, are we stopped? Case, are we chasing the player? So now all of the code for each of these states would go into here. Pretty simple. But we do need a few more things. For instance, we do need to know what are our waypoints. Where are we? Where is the enemy trying to go? We need to set those somewhere. So we can set those as a variable, as a class variable. So we can set that as vector3 and an array of vector 3s. And we can call that it's waypoints, is probably the most on the nose. And of course, we can make it public. Can't forget public. So by making a public array of waypoints in the actual editor, we can set, there's 4 of them, and we can set individually the 4 corners of where we want it to go, so it walks in a circle. You look confused.
No, I'm trying to make groceries because my roommate's going to the grocery store right now. I'm trying to think what I have.
Okay. So we've got our waypoints, and then we're also going to need one more thing. That is int current waypoint. So we do need to keep track of which one we're on. Otherwise we're just going to keep walking to that second waypoint and never do anything else. So we can of course set the current waypoint. I'm actually going to set it to 1, even though we have 0, 1, 2, and 3 for the 4 waypoints. I do want to start walking from the 0th waypoint to the first one, just at the beginning. So let's see. So first of all, we can set up some of the things we do know will be easy. So if we're doing chasing, so how would we know whether to chase? First of all, that should be exactly. So what we can do is we can just state can see is true, and if we want to just put it in the same place, cut out another if statement, we can just put current state is equal to state.chasing. So if we can see the player, we immediately start chasing. And then in the player, you can put if we can't see the player, if we can no longer see the player, current state, we can just put it back into walking, I guess. That it'll just immediately start walking to the next waypoint. Pretty simple. And I believe that's all for chasing, actually. What do you mean? We do have that because we've got if. We've still got the if you can see them, move towards them. So we should, that should be pretty much it for chasing. So in terms of stopping, so when we want it to pause, so we want it to walk to a point and then stop for some amount of seconds. And there's a few ways to do that. One of my favorite ways is to create a coroutine. I'm a big fan of those. What do you guys, coroutine, cool?
I love
Coroutines are so nice. Oh my god. All right, we'll make a coroutine because coroutines are beautiful things, really. So underneath update, there's underneath update. I'm going to create an I enumerator, and I'm going to call it stop moving because I'm clever with names. So there's my stop moving, and I'm also going to give it a float delay inside of there as a parameter. So what this is going to do is it's going to take some value and it's going to say for that amount of time don't do anything, and after that amount of time switch to something else. So what we can do is we can simply put yield return new wait for seconds, wait delay number of seconds, and after that we can put current state equal to state.walking. Pretty simple. So all that does is it says wait, delay number of seconds, and then you can go right into walking again. We do need to keep track of if we've actually started this coroutine already. So I guess a Boolean would just make most sense. So we can just create a bool as I'm just adding variables up here. Yeah, this isn't the best practices. You'd probably want to structure this a bit better. But I'm just going to add bool already stopped. I don't know. I'm running out of good names for things. So this is basically just checking have we already stopped, so we don't start one coroutine every single frame to stop, because that's just going to be unnecessary. So we can just check if we've already stopped, and already stopped is going to default to true or to false. So we can say if I haven't already stopped, this is in the case stopping block. If I haven't already stopped, then start coroutine, this is the command, and we give it stop moving, I believe it was called, yep, stop moving, and we'll give it, give me a number of seconds that it would stop. 3 seconds. 3 seconds. Start coroutine, stop moving. And now we tell it we have already stopped. Don't do it again. Don't keep creating coroutines. We also need a statement that actually lets us know when we have not stopped. So what we can do is in walking, the first thing we can do is we can just tell it we have not already stopped yet because we're not walking. I just realized that too. I was just thinking that as you're right. That would be better. It's equal to false. It would be better to just put it into the coroutine itself, into stop moving. Again, kind of improvising this, and I welcome suggestions, please. So yeah, so if we put it in there, the only thing we do need to change is we do need to switch the order of these. No, we don't. What am I talking about? I guess. No, I'm an idiot. Okay. No, I'm just being stupid. We're good. We're good. We're set. So now we actually need the walking part. So this is pretty simple. We can just walk towards the waypoint we want, and if we get to a certain... No, if we just reach the waypoint, then we just switch to the next state. Pretty self-explanatory. So first of all, I'm going to set my direction. Vector 3 direction equals, and we can just put waypoints current waypoint. So this is the position of the waypoint that we will set at the top here with this public, and we're just getting the current one that we're pointing to. We're pointing to one of the waypoints. So we're pointing to waypoint number 1. And then we need that minus our current position. What's up?
Are you sure you want to start current waypoint 1 if you're using it as an index?
Yes, because we would place it at the 0th position, the 0th waypoint, and then it would just move to the first one first.
Gotcha.
That makes the most sense to me in starting out the program. You can do it however you want, I suppose. So this is the direction we want to be moving. Now we could do physics-based movement, with our walking, kind of like when we see the player. The only issue with that is it's a little bit harder to correctly gauge how fast you want to move, because then you get the issue of, oh, I want to go to the waypoint, zoo, and then the next waypoint, woo, and sort of just starts making this weird circle that occasionally loops because of how fast it's moving. So we're just going to do simple positional changes. Really, really basic stuff. So we can do transform.position plus equals, same way we did it before. And we're going to put direction dot normalized times time dot delta time, or times speed times time dot delta time. Quick, point out something wrong with this.
Your speed is super high right now.
Yeah, speed's like 1,000. That's not gonna be great. So if we're using two different speeds, probably a good way to just separate them. So I'm going to rename speed to your walking speed and chasing speed is probably the best. So this will be chasing speed, and then this will be walking speed. So we'll just have two of those, and it definitely needs to have a type. Pretty sure. So now that we've got a walking speed and a chasing speed, we can run over to here. And this should now be our walking speed. So this is, we want to move at our walking speed, not our chasing speed. Okay. So right now we've got our basic state machine laid out. The only thing we need to implement is actually moving from one waypoint to the next. So when we reach that first one, we move to the second one. So easy way to do that. If vector3.distance from me to the current waypoint is less than some arbitrary distance value that's really small. So 0.2, I'm going to say. See if this works correctly. So basically, if we are a certain distance from it, we're just going to count it as we've made it. We did it. We're there. Great. Pretty easy. Or actually, better yet, we can even do this. We can just set this is better. We can just set our position. So if we get close enough, we just move to the waypoint. We're there. We did it. The next thing we want to do is we want to say current waypoint plus plus if current waypoint is greater than waypoints dot length waypoint is equal to 0. Okay, so greater than -1. Yeah. So this is pretty simple programming. I could really, if I wanted to write this better, I'd probably just take the current waypoint mod 4 or something. If I wanted to not have to reset it to 0 constantly and just let it count up to whatever. Kind of up to preference, but.
Greater than or equal to.
Is it greater than or equal to? Well, no, because I'm setting it up here. So if I've got 4 and it's at 3, 3 would be okay. That's fine. So if it goes from 2 to 3, God, now I gotta think. If it goes from 2 to 3, that waypoint is still okay.
What if it goes from 3 to 4 and equal to the length, which is 4, and you can't access the index 4.
Yeah, but I'm getting the length minus 1. So that would be
Oh,
giving me
okay.
3. You're right. I could do like greater than or equal to. You know what? Just for you. There.
I didn't see
The
that.
minus 1 threw you off. So yes, you're right. Yeah. Okay. So then the last thing we need to do is simply set our current state to state dot stopping. All right. This shouldn't break. We'll see. Let's give it a shot. And then we'll just fix the plethora of errors that pop up.
Doing the good old waterfall
Plethora,
method.
whatever. What?
Doing the good old waterfall method. Just do it all and hope it works.
Yeah, basically. I'm not getting any errors, so now we need to set our waypoints, of course, because right now we've got none of our waypoints set. So chasing speed, I believe, was 1,000. Walking speed, we'll put at 10, same speed as the player. That's fine. So now we've got our public waypoints array over here with size 0. So I'm going to give it size 4. And that will create 4 elements. So these are all vector 3s. So our first position we're going to do is one of these corners. So let's find a good value. Negative 12. 12? That looks like it's right around the edge. So this can be our 0th. Will be negative 12, 12. With the x and the z. Do not put it in the y. That will make for some really silly stuff as your character starts flying up into
You'd
the
probably
sky.
be able to see it.
What?
You'd probably be able to see it from up there.
See what?
The enemy could probably see you if he was up.
Oh yeah, you're right, because it would be pointing down and above, and you have nowhere to hide. Yeah. So we've got negative 12, 12. Then I believe it would be 12, 12 for the next one. So 12, 12. Then 12, negative 12, negative 12, negative 12. And it needs to be set at negative 12, 12. Okay. I'll go ahead and give you guys a second to look at those values. So assuming we did any of this right, something good should happen. Uh-oh.
Do you classify that as good?
No.
Wait, is it going... Did you mess up the order? Is it trying to down left?
No. It's I think it's not actually reaching the point. Did it just fall over? What happened? Okay, stop chasing me actually.
I think it did fall over.
I think it's something with this.
Are your Y values high enough on your waypoint? Because the
Oh!
plane is at a Y value.
You're right. That is the reason. Thank you. Yes, that's right. So actually, all of our Y waypoints need to be 1. That makes sense. So it was trying to go to some spot in the floor, and it was like I can't, and it was just getting stuck.
And it fell over.
It's a learning experience. So let's see what this does.
How did it fall over? Isn't the rotation...
I don't think it fell over. It's fallen over. You good? Leave me alone. Oh, you know what? That's silly. Okay. So, fun fact. Our rigid body velocity was still doing things while we were walking. So one of the things we should probably put in walking is rb.velocity is equal to vector3.0 to actually keep it from
So you don't mix
flying
up,
off into the heavens while it's trying to walk. So that should do that. The other thing we should do that I totally did not forget to do is in our walking we should copy setting the forward direction from lower down. So I just grabbed that from over there. It's just setting. So these are the two lines that I just added. Setting the transform.forward equal to our current direction. Just kidding. We can just put this with direction. So we're setting our forward vector to the direction we're facing, the direction we're moving, and the rigid body's velocity to 0. So as you can see, state machines kind of get a little bit antsy depending on how many states you put in and what you're trying to do. And the fact that we're switching between physics-based movement and regular movement is kind of questionable design decisions, but
switching between kinematic and dynamic.
So let that build while I keep this up. So does anybody need to look at this longer? Still just those two changes.
I have an issue with the waypoint.
Do you have the Y set as 1 in all of them?
I don't have.
Did you make them public?
Probably. Yes.
So does it look like this?
Yeah.
And what is it showing up in your inspector as?
It just says waypoints, the drop down arrow that has size equal to 0.
So if you type in 4 in the size, it generates 4 of those. That's what that does. Yeah. It's kind of goofy how it's set up. So let's see if this runs at all correctly. Okay, it's facing the right direction. It freaks out. What in the world?
Yeah.
How is it falling over? It literally can't rotate.
Well, one is right where the plane is, right? You want to set the Y a little bit higher.
What?
One is exactly where the plane is, right?
Where the enemy is.
Yeah.
Oh, so the plane.
So that shouldn't have any problems. Now let me do this. While I'm stopped, let's just cut out the middleman. Shoot. Can't do that.
You can set it equal to.
No, because it'd be the last waypoint at that point.
You can subtract one. Mod.
Yeah, but then I'd have to subtract one, and then I'm like, if it's at 0, set it to that. That sucks. That is why I would use mod, but I'm not, so sorry.
I think you still could.
Yeah, but that would.
It's really used like mod equals.
No, I know, but I'd have to read.
Wait, would it be? Yeah, you're right. Questioning your previous design decision.
Yeah. You know, I'm just gonna call this a success because I want to move on to something else. So this should call this a success. Yeah.
Good job.
This should be a good introduction to some basic enemy stuff. Just getting them to move, getting them to actually lock onto you, doing things like line of sight. If you wanted to do a better line of sight, you could simply set it so that not only is it pointing a ray at you, but is it also facing the right direction. So right now we've got this nice light letting us know which direction is the right direction. which direction it is facing. No, damn it. We've got a light showing that we know where the enemy is facing, so we could simply set it so that it's actually facing the right way when it spots you, so that it only spots you when it's facing like that. That was unfair. But if people are interested, I can go over Nav Mesh, so doing actual pathfinding, because Unity has a lot of stuff built in. Because I will say this, it will take like 3 seconds. Are you guys interested in that, or should I hold off until next week? Or next week? Okay. Well, first thing you got to do is go to a GitHub page then. So Unity does not put a lot of Nav Mesh stuff into the actual ordinary installation. And I'm not really sure why, to be honest. It's kind of a strange decision on their part, to be honest. Maybe they just don't trust game developers that don't look for it to actually use it correctly. I don't know. But this is the GitHub that you want to go to. So you can look up, probably an easier way to do it is if you look up Unity Nav Mesh GitHub, just like that, on Google. It'll probably be the first option. Yep. It's called Nav Mesh Components. Has anybody not found it? Does anybody need time to find it? Just making sure. Okay. So under here, there's a bunch of stuff that you can deal with. All we care about for this is we care about assets and Nav Mesh components. This folder, because this holds some simple stuff, including the scripts that we want to use. So what you can do is you can just download the zip for this whole thing. And then I'm just going to take the easy way out and go in here and select the Nav Mesh components inside the assets, the thing that I want. And I'm just going to drag that sucker directly into my Unity, because I'm lazy and why import things properly. Great. So does everybody have this now in their Unity project? Do I need to go over that again slower? I kind of went through it quick. We good? Okay. Just making sure I don't leave anybody behind. So, how did I fix this? There is one. Oh, you know what? That's the. I'm an idiot. Okay. Remember that thing I just said you to do and then you did it? You probably need to redo it. I did this wrong last night too when I was trying to do this. So, fun fact: you need to get the right version of Unity for this GitHub thing. So, if you highlight Unity as it's open, if you're on like Windows, it'll tell you what you're using. So I'm using 2018.2. This GitHub has different branches with different versions that you can get it from, including 2018.2. So I'm going to select that branch, then re-download it, the shameful re-download. And then I'm going to delete this from my project and put in the right one. I was totally reminding myself to not do this anyways, so oops. So just get the right version first. And then just drag that sucker in. So does everybody have, get out of here. Does everybody have the right version of it so they don't have errors popping up at the bottom telling them that the scripts don't work? Excellent. So this is where things get really, really convenient. So the first thing we can do right away is we can use something included in Unity. And that is we can go to our enemy and we can delete our rigid body. Because who needs rigid bodies? You can, by the way, if you want to save this code for later use, I would comment out all the stuff we're going to do with the code. I'm just going to delete it, but I'm just trying to show what you can do with this nav mesh. So, yeah, great. So we do want to keep our enemy script, but we can add a component. And if you just search nav, there are two things included with Unity: Nav Mesh Agent and Nav Mesh Obstacle. Obstacles are things basically in your path. So you could set them for like the walls, for instance. Agent is basically the object that you want to be navigating. So this is our enemy. So you can add Nav Mesh Agent, and you get a whole bunch of stuff. Trying to remember what speed I had it set to. I think it was 20. But you can set it to some speed. But otherwise, we don't need to touch this. We can just completely ignore the Nav Mesh Agent for now. Because now we can get to the cool part. So if you select the plane that we're using right now, we can add this magical little thing called a Nav Mesh Surface. This component. So if you search nav again, you'll find it. And when you select that, and then you click bake, it does something absolutely magical. It does all the pathfinding for you. That was easy. So now we have this thing that lets it know what is the fastest path from any point to any other point going around these obstacles. And that took literally 5 seconds. So it's pretty wonderful. Big thing to note though, you can select what layers you're actually going to use, and you can also select whether to use rendered meshes or physics stuff. So I'm going to select physics because anything visual shouldn't be blocking it anyways. And the other thing I need to put the player in another layer, because if you notice, the spot where the player starts is determined as being an obstacle. And even if the player moves, that will still be an obstacle because it's not changing. It's not using changed obstacles. It bakes it at one point and then uses that in the future. So we do need to set the player as something else. So I'm just going to take player. And what you can do is you can just add a layer. So I've selected player. Top right layer. I'm going to hit add layer. And under post-processing, I'm just going to make it called player because that's easy. And after you add the layer to the list, don't forget to go into player and also assign it, because it will not do that automatically. And so once you have the player in its own layer, way too much rhyming in the last 5 sentences, you can go back to plane and you can just, when it says include layers, you can just deselect player. And when you hit bake again, you'll see that it will fill that spot with the player. Neat. So, right now the only issue is our enemy doesn't actually know where to go. It now has all this complicated stuff set up for where it should, how pathing should work, but we do need to actually assign it a target. So we're going to go into our script and we're going to gut everything. So our whole state machine that we just put our blood, sweat, and tears into, I'm going to comment out. Anything with rigid body stuff, I'm going to comment out. Definitely keep this. Keep this because that's nice for things. Keep the distance bit, or is the player in the light. I'm gonna get rid of this coroutine. Don't need fixed update. Cool. One thing to note: definitely get rid of the rigid body because it no longer contains a rigid body. We got rid of that. You can keep the rest of the variables because we don't really care about those right now. The important thing is how easy it is to set pathing with Unity using this. So we can add 3 lines of code that will do it all for us. 2 of which are trivial. So the first thing we need to add is we need to add a Nav Mesh agent. And we'll just call it agent. So this just gives us a reference to thing attached to the player, which means this line is just agent is equal to get component Nav Mesh agent. Wowie zowie, that was quick. So that's pretty simple, kind of like what we do with rigid bodies normally. And then all we need to do in update is agent dot set destination to player dot transform dot position.
I feel like it's a secret agent or something.
Right? So once you have those 3 lines, and once you've deleted all of our hard work or commented it out, then you can run it. So, neat. Let's see what happens. There's our enemy. Oh, they're going for us. Oh, they kind of suck. Okay, that was easy. Oh, damn it. I say they suck and then they don't.
Calculated.
So right now our enemy does not turn very quickly. So in our Nav Mesh agent here, I believe setting a really high acceleration will get it to reach max speed quicker and turn quicker. You'd think angular speed, right? Everyone here is thinking angular speed. Like, of course, angular speed would be the thing you would change. Yeah, but that's not. It doesn't like you'd think that would change how quickly it rounds a corner.
It
doesn't.
turns, but it's not how quick it starts going in that direction.
Yeah, acceleration is what's determining that stuff, which I expected angular speed to change how quickly you go around corners. It doesn't. So acceleration we can just put at like 1,000, some arbitrarily large number, which basically means it just goes straight to its max speed and then turns like on a dime, basically. And bada bing, bada boom.
He's gonna hit you.
Oh, Jesus Christ! Okay, his speed's a bit fast. Let's turn down that speed a little bit. 20's terrifying. 8, yeah, that's what I was thinking. 8's probably a bit safer.
Does he eternally run away from him? Does he eternally run away from him?
Yeah. Hopefully he won't catch up on us that quick. But now we've got pathfinding. So regardless of where we go, he will navigate around obstacles and try and get to us. Yeah. So pretty basic, very short setup. Obviously this doesn't work if your game is not set up similarly to this. If you don't have a relatively flat thing, you can set it to climb certain angles and whatnot, but there are obvious limitations to this.
Does it work with any dynamic moving platforms or something?
I believe with moving stuff it won't work the same, at least for baking like the surface. I believe if you set up something, so if I set up like one of these walls and I gave it an obstacle, I believe then it would properly, you could then make it dynamic, I'm pretty sure. I haven't done too much with Nav Mesh, but it is a really, laughably easy way to set up some pathfinding for a lot of stuff, which is really convenient. So that's all I had today. Thanks for coming. Thanks for tuning in to the people at home. So hope you learned something. Sorry it was kind of a disorganized mess, but that's sometimes that just be how it do. So.
They say it don't be like it is,
But it do. All right. Go forth, make games, be awesome. Thanks.